the question of chi-square which was remaining. It's a little different, not totally different. It's supposed to be super tough in chi-square, but in statistics there is just more to offer, more difficulty to offer, you know. So theory predicts properties of beans in four group A, B, C, D is 5 is to 3 is to 3 is to 1 in 1600 beans. Experimental numbers 882, 313, 281 and 818. Does it really support the theory? Critical value 3D F and 5% LOS, 5% LOS is equal to 7.81. Something of significance it means. But yeah, this is actually a biology question, bioinformatics, Mendel's theory question. uh, this is statistics, so it comes in data science, which is used in bioinformatics. By the way, I don't know why. Don't ask me why does maths come in biology. It's supposed to be a total different thing, but yeah, when biology became stronger, it had more and more values. Then more and more values to calculate. Then notebook became insufficient. Bioinformatics came in, computer, maths, everything came in. When you spot pattern, definitely maths comes in. Actually, biology arena was away from mathematics, but Mendel and statistician, I don't remember his name. I guess Ernst Mayr or someone. I don't remember. Oh, Punnett, yeah. Who made Punnett Square? They came up to make statistics for math, biology. They started it, I guess, and things happened between them. So yeah, let's do this. First, for this, we have to find. Wait a second. What? Okay. Hmm. Wait a second. So these are observed values. So you would definitely know chi-square is equal to summation of O minus E whole square. E is expected frequency divided by E. Okay, expected frequency. So we have it all here. So observed frequency is where did we lose it? Yeah. So observed. So this is observed frequency. Okay. Oh, wait a second. Where are you? Camera. Okay. Yeah. Camera focus just goes again and again. Yeah. So experimental values means these were observed in an experiment. So these are observed values. Okay. And this ratio gives us expected values because theory predicts it, like it should be expected, it is standard, it is the correct one, it is the accurate one. But we got in experiment these experimental observational values. Okay, so by the way, degree of freedom is still n minus 1. So yeah, by the way, there are 1600 beans, right? So this is a ratio. Okay, this is a ratio. Okay, so this is a ratio, but we need numbers. These are numbers. Okay, these are numbers, and we are operating with numbers data, but we got a ratio, so we have to first convert it. This observed frequency, we have to first convert it into numbers. So ratio is 5 is to 3 is to 3 is to 1. So total is 1600 beans. Okay, ratio means uh, these are means they have common denominator, like whole when these all are added, that makes whole part or 1, okay, because it is totally means common factor is removed. So they are parts of the same they are parts of the same pie. They are fractions with common denominator. So these are totally simplified, actually simplified fractions. The common factors were taken out, so they have 1 beneath them. So when you add them, it becomes 1. So like their denominators is sum of all of these, okay, 5 plus 3 plus 3 plus 1, okay, this is the denominator, like the whole part, okay, this is part of it, okay, and this ratio is multiplied with this because the common factor which was taken out was 1600, okay, so I would show you how it works. 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 1 12, okay, 12 is the denominator, 12 was the whole part. So 5 by 12. So out of 12 parts, we took 5 parts, like total parts. When we add these, we get total parts. Okay, these were totally exclusively divided. Okay, exhaustively divided. Like there is no part except this. So when these are added, a complete piece comes out. Okay. So 12, 5 parts are taken out of 12, so 5 is in numerator, 12 is in denominator. But since it is a ratio, a common factor was taken out, that common factor was 1600. So we have to find which was the real number, okay? 1600, though, so 2 6 are 12, 2 8 are 16, 800, 2 3 are 6, 2 400, okay? 400 into 5 is, okay, 400 into 5 is 2000 by 3. Now similarly with 3 by 12 into 1600, but here 12 and 3 gets divided, 3 4s are 12, 4 uh, 4s are 16, 400. So this is 400, this is 400, this is 400 because they are same. And 1 by 12 into 1600 is 4 threes are 12, 4 fours are 16, 400. 400 by 3. Wait a second. Oh, okay. 2000. Okay. So we got all 4 observed frequencies. So these are of observed frequencies. Okay. 2000 by 3, 400, and 400 by 3. Okay. So we have to subtract each expected frequency, which is this one, from observed frequency. Okay. So O1 minus E1 is equal to a which is the first one, 2000 by 3, okay, 2000, wait a second, here it is, 2000 by 3 minus 882, okay, this is first one. Second one, sorry, here, second one, second one is 400, right? Yeah, 400 minus 313, okay, 313, it should be E1 not E2. I made a mistake, sorry. 400 minus 313, so 400 minus 300 is 100, 100 minus 30, 100 minus 10 is 90, 90 minus 3 is 87, 87. O3 minus E3 is equal to 400, because 5 is to 3 is to 3 is to 1, so second ratio is also same, 400, okay. So yeah, this was denominator, you got it right, 1600 multiplied, okay, 1600 beans were there. So yeah. So 5 by 12 is equal to 1 by 1600 it was, then it came up. So yeah, that's how it was, and it became like this. Okay, 400 minus expected frequency is 281. 281, then 400 minus 200 is 200. 200 minus 80 is 120. 120 minus 1 is 119. 119. O4 minus E4 is where is it? 118. 400 by 3 minus 118. 3 minus 118. 318, right? 3 8s are 24. 3 8s are 24. 2 remains. 3 1s are 3 plus 2. 5 3 1 3 minus 400 minus 354 by 3. So we have 400 minus 300 is 100. 100 minus 50 is 50. 50 minus 4 is 46 is equal to 46. Here we go. Now this one 3 882. Okay, 3 2s are 6. 3 8s are 3 8s are 24. 2 3 8s are 24. 2 26. 2 6 4 6. Huh? Bro, what? This gonna be coming in negatives. Negatives, bro. Whatever. Okay. Oh, I can't believe it. Okay, 2646. 2646. Oh boy. 2000 minus 2646 is minus 646 by 3. Minus 646 by 3. Okay. Now we have to divide it by expected frequency. Okay. So let's divide them, each one of them, with expected frequency. Then first I have to erase this all. I hope you have taken notes. Right. Erase this. Then we are gonna erase all of this. Erase, 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 eraser, 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 erase, 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 erase. So now let's do this with O1 minus okay, we have to take its square too. So minus wait a second, O1 minus E1 whole square by E. So minus 646 by 3 divided by expected frequency. What was the expected frequency? 5 no 5 by 12 into 1600 was 2000 by 3. Okay, 2000 by 3. So numerator denominator became denominator into 3 denominators. Denominator became wait a second, what just happened? What just happened? Wait a second. 646 by 3 divided by 2000 by 3, which actually means 646 by 3 multiplied by 3 divided by, wait a second, yeah, so 2000 by 3 divided is 3 by 2000 multiplied, because numerator and denominator are opposite, replaced, and divided is opposite of multiplication, so 3 3 gets cancelled. This is the answer. Okay, let me write it. 646 by 2000. Okay, yay. Whether let's write it out. Little visible type. So O2 minus E2 whole square by E is equal to okay, O2 minus E2 whole square by E is equal to mm, is equal to okay. So we have to take 87 square. Wait a second. Didn't we have to take it square? Oh boy. I just made a huge mistake. Square, okay. So there would be still okay, there would be 3. This is 3 into 3, 1 3 remains. Okay. Now 3 remains. Then this would be 6,000. 6,000. And this would be 646 square. 646 square, okay. Now 87 square by expected frequency was 400, okay, because 3 by 12 into 1600 was 400, okay, simple. And O3 minus E3 square by E is equal to 119 wait a second, what, 119 square, yeah, 119 square by 400, okay. O4 minus E4 square by E, that is 118 by 400 by 3, 400 by 3. So numerators denominator becomes numerator, so it is like this into 3, 118 into 3, okay. Wait a second, okay, we got this answer by the way. No, okay, see this by the way, huh? So 400 minus 354 was 46 by 3, okay. I forgot to mention this 3. So actually it is 46 by 3 divided by 400 by 3, okay. 46 by 3 divided by 400 by 3. So numerator's denominator goes to denominator. Denominator numerator goes to numerator. Here we go. Problem solved. Huh? Wait a second. But this is square actually. So 9. And this is square. Okay. 3 square 9. Okay. This was square. So cut. 3 remains. So this is 46 by 4 3s are 12. Okay. 1200 square by the way. Now your next task is to find summation. So add all of these, then you get summation of OE square, okay. So chi square equal to, ouch, chi square equal to minus 646 square by 6000 plus 87 square by 400 plus you can see them all above, okay, plus 119 square by 400 plus 46 by 1200 square, okay. So you have to find common number that all of them can reach by multiplying, and you have to multiply that above and balance them, so the denominator becomes common and numerators can be added easily. Like 400 is common, but they can go to 1200 and 1200 is there, so 400 into 3 is 1200, but we need 60,000, so 12,000 into 5 is 12 into 5 1200 into 5 is 6,000. So 3 into 5 is 15, so 400 needs to get multiplied by 15. Let me show you. this would remain as it is. Okay, so 6000 would come in common, because uh, plus 87 square into 15, right, into 3 into 5, okay, into 5, okay, into 3 into 5, into 3 to reach this, into then into 5 to reach this, because this is also trying to reach this. Okay, now plus 119 square into 15 plus 46 square into 5, simple. Okay, now you have to add this to get zeta square, chi square calculated. By the way, this symbol is called zeta, I guess. But zeta square calculated, if it is smaller than zeta square table, then null hypothesis H not accepted. Like whatever question is saying, it is correct. Like it is it supports the theory. Okay, in question it was like, does it support theory? Then it supports theory. How to find zeta square table? Let's go behind. I told you degree of freedom is n minus 1. So degree n means how many number of data. So how many data are there? 4 group already written, A, B, C, D. So we had 4 ratio, here we have 4 number. Okay, okay, and also in question critical value of 3 DOF was given, so it is already 4 minus 1 3. Okay, we take alpha always 5% mostly. So in table you can look it out by row column thing. It was already given in question 2, level of significance, 5% level of significance, and 3 degree of freedom. Critical value was 7.81. So we already got 7.81 as critical value. Now that you can compare with our zeta calculated, and you can take the decision if H naught is accepted or not. Like the formula we used to calculate zeta. Okay, the formula we used to calculate zeta calculated, if it is smaller than zeta in table, then H naught null hypothesis is accepted. First we have to define H naught and H also, HA, which is question and opposite of question. So let me zoom it out so you can take screenshot. I hope you have taken screenshot. Yeah, let's go. Thanks for watching. Like, share, subscribe. See you next time. Your stats syllabus is completed, I guess. Yeah, stat syllabus is completed, I guess. From PYQs, 5-year PYQ, what questions I found, unique questions are completed. So yeah, thanks for watching. Bye. See ya. Like, share, subscribe. See you next time.